Welcome to Combinatorics Notes 3 on permutations involving identical objects. The problem is that when we have repeated objects, and you'll remember from our last lesson that we had objects which weren't repeated, meaning all different letters in words. So here we have repeated objects. We need to do something a little bit different. So what I want you to do is to take the time and write out all the permutations of the word fuel. And there should be 4 factorial, 24 permutations of that word. I would strongly suggest using capital letters for this and just get into a pattern, write them all out. So now would be a good time to hit pause and write out the 24 permutations of fuel. Once you have those 24 permutations written out, what we're going to do is we're going to build a little table just talking about the number of letters, the number of repeats, and how many different words there really are. So we can see that if we have 4 letters, this is our starting case, with no repeats, we have 24 different words, which comes from 24. I'll explain the second column in a second here. And that is 4 factorial. And that comes from the word fuel. So let's change this a bit. Let's take every F and turn it into an E. That's the main reason why we're using capital letters here. So as we turn every F into an E, we start to see words that are the same. For instance, E-U-E-L is going to be the same as E-U-E-L. It's the same word. So complete that. We've changed it to E-U-E-L. We have 4 letters still. We have 2 repeated letters. Let's count how many different words we have. So what can we get rid of? Let's just cancel off doubles. E-U-E-L is going to get rid of E-U-E-L. Do I see another E-U-E-L? There we go. E-U-L-E. Well, it looks like this whole column for myself is the one that's repeated. U-double-E-L. So take the time, find all the repeated ones, cancel them off, and what do we end up with is 12 different words, which looks a lot like 24 divided by 2. What about when we change the L's to E's? So now what we're doing is we're increasing the number of repeated letters. We only need to do it to the ones that we haven't crossed off yet. Still starting with 4 letters. 3 of them are the same now. Let's cancel off the ones that look like repeats. E-U-E-E. Looks like we're canceling off 2 per. So there's double E-U-E, triple E-U. And what we end up with is 1, 2, 3, looks like 4 different words. So that's 24 over 6. And finally, let's convert everything to E's. Unfortunately, the U doesn't really work out that well. Converting everything to E's. we get cancellation again, everything else, and we're left with just one word. So 4 letters, 4 repeats, down to one word, so that's 24 divided by 4. Take the time, complete that table for me. Really what we want to look at here is this table, and we want to try and see some patterns. If we look at the whole idea that it's based off of 4 letters, 4 factorial for each of these things, because that's what 24 is, we are dividing by a specific number each time. Now, you could probably find some patterns if we take 4 factorial and we divide it by 2 in this case, 6 in this case, and I've made a little error. We're dividing by not 4 here, we're dividing by 24. How can we generate those numbers 2, 6, and 24 based on strictly the number of repeats? Well, if you've worked enough with factorials, you're probably going to figure out that 2 factorial is 2, that 3 factorial is 6, and that 4 factorial is 24. So it looks like we're dividing by the factorials. So we can formalize this a little bit by saying the number of permutations of n objects, again, so n is the total number of objects, just like in pick. If there are A repeats, and A is an amount, B repeats, etc., etc. So we could go up to C repeats, D repeats, whatever. Looks like it's n factorial over A factorial, B factorial, C factorial, etc., etc., etc. if we had an A, a B, a C. So there's our handy little formula for this. Total number of letters over the repeats. So determine the number of different, and this is the key, the number of different permutations of the word. Let's start with parallel. P-A-R-A-L-L-E-L. So we see parallel. We still are talking about permutations where order matters. We're not going to be able to use pick and use factorial in that sense, but we will be able to use factorial in the sense of let's figure out how many numbers, how many total letters there are. Looks like we have 8 letters. And what we're going to divide by is we have 2 repeated A's, we have 3 repeated L's. So let me maybe make note of that. This is total number. That 2 is from the A's. That 3 is from the L's. I don't think we have any other repeats, only 1 P, 1 R, 1 E. Roll that through the calculator and we end up with 3360. Why don't you try the same thing? Let's go with something a little bit bigger, parallelogram. Now is probably an opportune time to hit pause, take a minute, discuss with your neighbors on how to find the answer to this. If we look at it, usually counting the number of total letters is one of the biggest problems. We end up with 13 total letters. What do we see? P's, 1 P. How about A's? 1, 2, 3 A's. R's, I got 2 R's. L's, I have 3 L's. 1 E, 1 O, 1 G, 1 M. Perfect. So surprisingly, roll that through your calculator and you ended up with 86 million different words. This brings to conclusion the third unit on permutations involving identical objects.